Hello everyone, today I'm going to talk about homework 7 and question 7. So this question is given us that zt is equals to n1t multiply cosine function plus n2t multiply sine function, and theta is given that is uniform distributed in 0 to 2 pi, and N1t and N2t are y-sum stationary. So, and N1t and N2t and theta are all independent. So, the first question is asking about finding the expectation of zt. So, if we are given that N1t and N2t are y-sum stationary, we can easily calculate that expectation of N1t is equal to a constant number. We can write it as A, and the expectation of N2t can be written as B. They are all constant. So in this rule, the expectation of zt can be easily written as the expectation of the above equation, but we can easily draw the part of N1t and N2t out of this equation and calculate them separately or individually. So we know this part is equals to A and this part is equals to B. The left part equals to the integral from 0 to 2 pi. And we all know that cosine function and the sine function has a rule that if we integrate them from 0 to 2 pi, they all equals to 0. So the constant multiply 0 plus another constant double multiply 0 is equals to 0. The next question is asked about to find the RZ T1 T2 is that zt is y-sum stationary. So if we want to calculate RZ T1 T2 is a long equation, I have already write this transformation over here. So firstly, we know that is RZ T1 T2 is equals to expectation of ZT1 multiplied ZT2. We can write the equation above to write it as this long equation. N1T1 multiply cosine plus N2T1 multiply sine multiply N1T2 cosine T2 plus N2T2 sine function, and we multiply them apart. We get 4 individual parts, which the first part equals to R1 N1 tau, because we have N1 T1 and N1 T2. We can draw them. We can draw them back, draw them apart, and is equal to R1 tau. The expectation of N1 T1 and N2 T2, we can also draw them apart, is equals to tau theta 1 multiply theta 2. The third part is same, and the fourth part we can draw the N2 tau apart. So this question is, we can write it as clearly like this. And From above to this equation, we can observe that it can be written easily to R1 tau, Rn1 tau plus Rn2 tau multiply cosine tau, and is equals to Rz tau. So we can easily observe that Zt is a Y-sense stationary. We prove from above. So the third question is given us want to find Rz0. If Zt is a Y-sense stationary, we can easily replace t with 0, and we can replace t with 0 is equals to 1/2 multiply Rn1 0 plus Rn2 0, and is equals to 1/2 multiply expectation of N1 square t plus expectation of N2 square t. So that's the question 7.